Hello, this is Matt McKnight, Programming Mentor for Team 4536, and this video is about using the Git GUI or Graphical User Interface in Android Studio. Git itself is a program that is used to interact with repositories, both local and remotely, for example up in GitHub. If you are not familiar with Git and GitHub, I would strongly recommend you watch the video Why Git. There's a lot of good videos about why Git out there, but this kind of lays out why we use it, so you can kind of understand how local and remote repositories interact. We're going to see some of that in this video. Git itself is very powerful and is often used in the command line, but there are GUI interfaces through Android Studio that we're going to look at, and there's three main ones at this point that I want you to focus on if you're new. One is the commit, and the push, and the pull. And as we go through, you'll see which those are. We're also going to create a branch and push that out to the remote repository. So without further ado, let's get started. All right, what we're looking at in here is the repository which we copied locally from the remote repository up in GitHub. And we're going to create a new Java class called constants. So I chose File, New Java Class. We're going to have this at the root of our package here. Notice that the package matches the folder structure. org.firstinspires.ftc.team4536 matches the folder structure we have below. That's by default in Java, and it has to be that way. It does it automatically for you in Android Studio, so that's pretty sweet. So we're going to put in here a public final string. This is going to be a variable, and each of these words mean something. The ones in orange are special words. Public means anyone can see it. Final means there's only one, and we'll talk about how that works. String means that it's going to be a string object. Strings are simply a collection of characters. And we're going to give this a particular format. This is going to be a constant. Constants by convention are uppercase with an underscore between the words. That way, when you're programming, if you see anything like that, you know that it's a constant. So what we've done is we've taken the constant variable, drivetrain underscore motor underscore left, and assigned it the string value of left drive. In effect, what we've done is we created an ability to pull that string into whatever we want by simply referencing the variable of constants. So you could write in your code, and you will, something like hardware map.get DC motor class, comma, quote, left drive, which is totally fine and great. You can use this in another part of the code anywhere, but you can now also write hardware map.get DC motor.class, comma, and put in the constant. Notice there's no quotes around it. Drivetrain underscore motor underscore left. Now, I have to go back and correct this because I actually made a typo. It should start with constants dot drivetrain, and that's because of the final. The final makes it what's known as a singleton. Singletons enable us to call the properties of a class without having to actually create the class in the first place. So I can call the property of drivetrain motor left from constants without having to create a constants object. Well, let's say somebody changes drivetrain motor left to left side drive. That's what they're going to do it in the hardware map. They can change it here, and it will automatically be taken care of in the code because the constant drivetrain motor left is what I'm referencing. Otherwise, I'd have to dig through the code and fix that. By doing it this way, I am helping to enable the concept of separation of concerns. Some things are responsible for some things, and other things are responsible for other things. If I do it this way, then the person that's in charge of determining what the drive motor is going to be called in the hardware map can change it, and it will not affect my code at all, because my code is simply referencing the constants file. They changed the name there, and it doesn't matter to me in my code. Understand that in my code, I don't care what it is called in hardware map. I just want whatever motor is going to be referenced. So I will reference the constant drivetrain motor left, and they will call it whatever they want. They can change the name, and it will not affect my code. Now, I'm going to wipe this out because we don't really need this anymore. I was just demonstrating that to you, and as we go forward, you'll see how to use it. But the big thing that I want to show you is how we interact with Git. So up at the top here where you see the Git, there's three options. This one, the check mark, is commit. Now when you do a commit, you have to give a description of what you're doing. And there are certain ways that you generally want to do this. The first of all is you want to not have it be added. You want add. You want an action. So like one way to think about it is this will add constant Java class to the root of a project. And don't end on a period. That's just standard practice. Doesn't matter to the commit itself, it's more for the programmers. So this will add constant Java class to the root of the project. I put that in there, and I'm going to click on commit. We're not going to do commit and push. We'll talk about that later, because it's actually a two-step process. You commit the files and the changes that you've made, local repository, not to the remote one. Now, if we go to Git at the top there, and you choose Show Git Log, a Git log is known as the history of the changes that have been made. And if you notice, the difference between the local master and the remote master is a remote master is missing the commit we just made. To get it up there, we're actually going to push it up to the remote master. So I just want to show over on the GitHub, if I hit refresh, you notice the only file in FTC team 4536 is the README. We're missing the constants.java that I just created. That's because this is the remote. In order to get it up to the remote repository, we're actually going to push it up there. You can choose the Git menu, or if you simply click on the green arrow that points up and to the right, that will push it up. And if you hover over that green arrow, you'll see that it says push. Now the blue arrow that points downward says update project. That's a misnomer. It actually is pull. Push pushes up, update project, or pull pulls down. So to push me, pull me. You commit, you push, you pull. I click on push and it says this is what I'm going to do. I'm going to take it from local master to origin master. These are the changes. That's the thing. We click push and it does it for us. Now there's a command line you can do for this, but this will do it for you in the background. And now if you look at the remote master, you'll see that we have that history now of adding constants.java. Did it work? Well, the simple way to check is to flip over, hit refresh, and voila, there we have constants.java. So you write the code locally, you actually stage it, but that Android Studio doesn't do that. You commit it, and then you push it up. Now, if we pull, there's a couple choices. We're just going to accept merge. We're not going to worry about rebase at this point. That would take any changes that were up at the remote repository and pull them down. So we push up to the remote, we pull down to the remote. That's how it works. All right. We are now done with constants, but here's the thing. I want to create two subfolders. One of them is going to be commands and one is going to be subsystems. You do not do new folder. You actually do new package. And that's because every time you create a new subfolder, you're creating a new package. I'm going to type in commands and hit enter, and it will create a quote folder on the file system, but what it thinks of as a package. I'm also going to create a new package off of 4536 called subsystems. So now I have those two folders that are for packages. The thing is, if I try to commit, there actually is nothing to commit. And that's because Git deals with files, not with folder structures. So I'm going to trick it. I'm going to create a new text document. I'm going to call it placeholder.txt. It's going to be an empty file. It's like a 0-byte file. Git doesn't care. It's a file. So we'll happily push it up. Notice that now in the change list, I have that one. I'm going to create this, do the same thing to subsystems. I'm going to create a new file called placeholder.txt. And now if we go in and take a look at what we can commit, you'll notice that we can now commit both commands and subsystems. Or in Git's mind, we're actually committing the placeholders. So I'm going to put in here, again, add, not added. This will add commands and subsystems. If I can type correctly. I forgot the S. Subfolders to root of project. And put placeholder.txt inside. As you go forward, you're going to get better at naming these. This is not a great one, but it's good enough for the demo. Again, I'm just going to commit. I'm not going to commit and push. Sometimes when you're working on a project, you're going to do multiple commits before you push. All right, notice now that I've committed it, I have it in my local master, but not the remote master. What am I supposed to do? You guessed it, we're going to push it. We're going to push it up. And when we push it up, you're going to again see that our local master, which has that commit, is not the only one. Now, if we look in the origin master, we will see that it has the commit. And if we go over to GitHub and hit refresh, guess what? Now we have those two subfolders with the placeholder.txt file. That's the basic scaffolding we're going to work on for now. This is good enough for what we want. Talk about what I think is one of the most fundamental rules around using Git, particularly in teams, and that is you never work in master. What I mean by this is we've been working in the master branch. Master branch is generally considered production code. If you're going to work on code, what you're going to do is create a branch. So you notice when I clicked on Git, there's a branch choice up there, and we're in the master. We're going to create a branch called drivetrain. That means any changes we make and commit and push to drivetrain will not affect master until we merge them together. So Git, new branch, we're going to call it drivetrain. Notice the checkout branch. What that means is when we create drivetrain, we will check it out. That means that will be the branch that we'll be working in. You can also, there's a command for Git called checkout, which allows you to do it. But this is really easy. Type in drivetrain, make out checkout branches there. Click OK, and it will create a new branch locally. Again, remember, we only are working locally on drivetrain. So now what we have to do, guess what? What are we going to do? We're going to put it in the remote repository. So what do? That's right, we're going to push it up. We've created the branch drivetrain. Now we're going to push the branch drivetrain up to the remote repository up in GitHub. Here's a cool thing to check out. If we go down to the Git history, now you'll see on the left that under local we actually have two branches, drivetrain and master. Notice that remote still only has master. So we're going to have to push it up. Again, the GUI makes this very easy. You just have to go up and click on that green up arrow, and it will say, hey, is this what you want to do? You want to put drivetrain to origin drivetrain? We're going to push it up. But before we do, just to prove that this is doing stuff, I'm going to go here, and if you click, you'll see that the only branch is master. If we go into branches, it's only master. There is no drivetrain yet on a remote repository. But when we click push, it will automatically push that up there. And when we go back to our GitHub repository, we will find that not merely do we have master like we did before, but refresh, wait for it, drivetrain. There we are. Drivetrain is our branch. And in drivetrain, you'll notice we have all the files that were on what we made the branch from, which was master. All these files are from master. Now let's say we go into subsystem on drivetrain, and we create a new Java class called, let's call it drivetrain. Why not? That file is now put into the folder or the package of subsystems. Notice again, because it's in the subsystems folder, it's in the subsystems package. So we've got drivetrain in there, and that's good enough for now. We could muck with it and add stuff, but really this is a demo thing, so I'm not going to spend a lot of time on that. Really, what I'm going to do is I'm simply going to commit it. Remember, we do a commit, and then we do a push. So we commit it. It says, what do you want to say? And I'm going to say, this will add drivetrain.java to demonstrate, if I can type correctly, branches. Again, I'm not going to commit and push. I'm just going to commit. But then, now if we go over to the Git, and we look in the Git log, you notice that the drivetrain is not on the remote, but is on the local. But notice this. That commit is not in master. That's because drivetrain and master are different branches. And what I make to one does not affect the other. If I want them to merge or rebase, which is the way of combining the two, then I have to do that intentionally. This will keep your master safe while you're working on the other codes. All right, so I'm going to go over here and I'm going to push it up to the remote repository. Remember, I'm in drivetrain and I'm pushing up the add drivetrain to show branches. If I hit refresh, you will see that now in drivetrain, if I go into my correct folder of Team 4536 and subsystems, guess what? Wait, there's placeholder. That's because I secretly haven't pushed it yet. Here we go, we'll push it. And there we go, it's pushing it up. Gotcha on that one, didn't I? Well, when we flip back after it is pushed, first you'll see that it's showing up here as a commit. And when we flip over to the remote repository on GitHub and hit refresh, there is the file. So we've successfully pushed up a change, a commit that we made to the remote repository. Now, again, I want to emphasize that drivetrain as a branch is distinct from master. So if we go in and we look at master, we're going to find that that commit is not there. And that is true both for the local and also for the remote one. It means you can muck with drivetrain all you want. You don't have to worry about breaking master.